we'll talk about navigation in a sec. So, you can see the next tag down there is pink. This is plot 17, okay? These are the ripped rows that you'll be planting into. These tags are exactly 36 metres apart in this direction, okay? 36 metres apart. So when plants get planted at a 3 metre spacing, you can fit 13 plants. Your first plant starts right next to the tag, okay? And you go down and your last plant should end in the rip line next to that tag at even 3 metre spacings, and it's happy days. Okay, so as we cruise along here, you'll see, of course, it's pink, so we know that every plant in this plot is getting half a cup of the native soil, what we call nature dirt, okay? So as we move down here, hopefully it will become clear to me in a second. Yes, it is. This isn't a great example of a first plot because the rip line doesn't continue all the way to the end because of these obstacles here, but you'll get the idea. In fact, this is going to be relatively difficult compared to the others because this is a slightly odd plot. The rip line actually does continue to here, you can see it. The granulated compost that we're adding, which is on the pellets in there, on the pallet, the pellets are on the pallet, we get 1/3 of a cup. Now they get applied to every plot, but the rows differ by plot. So in contrast to the nature dirt, which gets applied to an entire plot if it has pink tags, this treatment gets applied to half the rows in every plot. It's what we call a split plot design, and it's how we can experimentally tease apart their combined and independent effects. What we've done for you in advance is mark a cross on the ground just to the south of every row that will get the pelletized treatment, okay? So this half of this plot will not get the chook poo. If it doesn't have a yellow cross at the start of the row, on the south side of the row, then it doesn't get it. You go down that end of the plot, you'll see another yellow cross on the ground at the beginning and the end of the rows that receive this. We tried to make it quite clear. So when you get to here, we go, okay, I now need, because I'm in a pink plot, I know that every plant needs to get half a cup of nature dirt because every plant in this plot gets that. And now I'm in a yellow row, I know I need 1/3 of a cup of the chook poo for every plant. We'll talk about with the planting team about how we want that administered, okay? So that is how this is done. Now the thing is that the row identities change, okay? And it's all, I can give you hard copies. If you have, we've got tablets with a project loaded on it that you can navigate with. If you use the KML, how are you proposing to navigate the site?
So we do have the KML file, but it doesn't have the colours on it yet.
Okay, so there's
We'll be sending that one around this morning, so Gavin should have it all. We can put it through
Yeah.
to Blair.
do you use a Venza map?
We got a
Yeah.
Venza.
Okay, so if you're going to use a Venza Maps, you're going to be able to navigate and it'll tell you what plot you're next to. And so you should be able to navigate and you'll see on there, okay, it tells me I should be at plot 17. It tells me it's supposed to be pink. Look around and find a tag, okay? And you'll be able to navigate quite easily. So I've just got it as a KML on Google Earth because I run iOS. I couldn't use the Q field, but it is there and we have it on tablets. If you have the KML on Google Earth, you can tap on the plot and it will tell you which rows should be receiving this chook poo, okay? Importantly for you to know, the rows are numbered in every plot beginning at the southern end. So if the sun's in your face, you're looking north. Sorry to be condescending, I'm just trying to be clear. In this plot, there are 13 rows. In every plot, there are 13 rows. Okay? They're all the same. This is row 1. This is row 2, 3, 4, and so on. In the files, the KML file or the QField file, if you're using it, I'm not sure about the Avenza product because I've never used it. you can click on the polygon and it will tell you in that plot, rows 1 to 7 are supposed to be getting the chook poo. Rows 8 to 13 are supposed to be getting the chook poo, and so on. So in addition to having them marked on the ground across all 120 plots, you should have access to data that corresponds exactly with that. Okay? If there's any doubt or you're not sure where you are, don't plant a tree until you're absolutely sure where you are and what's supposed to be happening. This sounds complicated at the start. I guarantee we'll get the hang of it, and we'll get a nice system going. The only other thing I should mention in terms of the species mixtures that's quite novel about this experiment, and something I mentioned to a couple of the planting team before, is for the 2 dominant species in this ecosystem, which are Eucalyptus terreticornis and Eucalyptus cribra, we've sourced both local provenance, so from around southeast Queensland, and seed stock that have been grown up in the nursery from near Middlemount in central Queensland. Now, the current climate of Middlemount is 100 mils drier a year, and it's warmer across all seasons. And that is in the same direction as climate change is predicted to be for southeast Queensland. I don't know if you guys are aware of it, but there's, I guess there's a challenging debate happening between the old dogma that local provenance is best. In the face of climate change, is it better to go and source stock from climates that are closer to the future climate? These plants are going to be here for 100 years or more. What's the climate going to be like in 50 or 100 years? Will local provenance become maladapted to that climate? And is it better to try something from a climate that's closer to the future climate? So it sounds far-fetched, a bit sci-fi, and I know with the sort of dogma of restoration that local provenance is best, and it's been punched into my head for the last 20 years. This experiment will test that for the 2 dominant species. So some plots will get all dry, some plots what we're calling the dry provenance, the central Queensland provenance, and some plots will get all local. And as the years come and go, droughts come and go, through time we'll be able to say which provenance performs best. It's something that we need time to work out. So this experiment, we hope, will yield interesting insights about this idea of provenancing. It's purely an idea at the moment. Not many people are trying it, a handful of people. In addition, it's testing interesting ecological theory from my point of view. There are particular expectations that we have about it. And we can use this as a UQ teaching resource. I coordinate 2 third-year courses at UQ in the ecology major, and we'll be coming out here with students over the years to use this as a teaching resource as well. So this is a very exciting project for us. And it's ambitious, and I'm really stoked to have this opportunity, and I should thank Turn Family Foundation for inviting me to throw my ideas onto a paddock, onto a page, and now onto a paddock. It's very exciting. So are there any questions about that before we kick off?